If you think humanoid robots are still science fiction, you're already behind. Industrial adoption has already started. And if you work in manufacturing, automation, logistics, or technical services, this shift will affect you directly. Let's remove the hype. Humanoid robots are not being developed for futuristic cities. They are being developed to operate inside environments that already exist. Factories, warehouses, logistics corridors, industrial maintenance spaces. Instead of redesigning infrastructure for robots, companies are designing robots that fit human infrastructure. That changes the timeline completely. If you've watched my coverage from Mobile World Congress over the past few years, you've probably noticed something. Every year, humanoid robots look less like experiments and more like deployable systems. Better balance, more stable gait, more precise actuation, stronger AI integration. At MWC, these machines are no longer just dancing demos. They are being positioned as workforce platforms, and that's the key shift. Now let's talk technically. Industrial robotics has existed for decades. Robotic arms, palletizers, CNC automation, AGVs, all mature technologies. What's new is not robotics. What's new is combining humanoid mechanics with large AI models. Until recently, robots could repeat tasks. They couldn't adapt. Now they process visual input in real time. They map environments dynamically. They respond to voice instructions. They adjust trajectories on the fly. AI has given them a decision layer. But here's where realism matters. Current humanoid robots still have significant engineering limitations. Battery autonomy under continuous industrial workload is limited. Thermal management is still a challenge. Fine motor precision under high-speed industrial cycles is not yet fully reliable. Integration with legacy PLC systems is complex. This is not plug-and-play automation, it is a transition phase. But here's the important part. The cost curve is moving. Current humanoid platforms range roughly between $50,000 and $100,000 depending on configuration. Now compare that to the fully loaded annual cost of an industrial operator in developed economies, including social costs and shift compensation. If reliability improves to projected levels, return OT investment in repetitive internal logistics roles could fall within 3 to 5 years. And companies are running those numbers right now. The first large-scale adoption will not happen in homes. It will happen in logistics hubs. Why? Because logistics environments are semi-structured, tasks are repetitive, margins are tight, labor shortages are real, night operations are expensive, large distribution centers are the perfect testbed. After logistics, expect adoption in structured manufacturing environments where repetitive support roles exist. Internal material handling, tool transport, basic inspection routines, night shift assistance. Now let's address the uncomfortable narrative. Robots will take jobs. That framing is too simplistic. Humanoid robots will not replace skilled technicians. They will not replace engineers. They will replace tasks, repetitive, physically demanding, structured tasks. And this changes cost structures. When labor becomes programmable and scalable, business models change. 24-hour operation without shift premiums, reduced injury downtime, stable output regardless of labor availability. This is not about replacing humans. It is about optimizing repetitive workload layers. But here's something many people miss. The ecosystem around humanoid robotics will expand. Maintenance of robotic platforms, AI supervision roles, integration engineering, performance monitoring, human-robot workflow design. If you work in technical services like I do, you already know something important. Machines do not eliminate maintenance, they create new maintenance categories. Now let's project forward realistically. Within 5 years, seeing humanoid robots operating inside major logistics centers will no longer be rare. Within 10 years, seeing them inside manufacturing plants will feel normal. Homes are different. Domestic environments are unpredictable. Safety standards are higher. Social trust matters more. Home adoption will be slower. Industry will normalize first. And once something becomes normal in industry, social acceptance accelerates. The biggest barrier is not mechanics, it is trust and reliability under real workload conditions. The moment humanoid robots operate consistently alongside human workers without disruption, normalization begins. And based on what we are seeing at events like MWC and in industrial pilot programs, we are closer to that threshold than most people realize. This is not a revolution overnight, it is a gradual integration curve. Just like collaborative robots a decade ago, just like AI and enterprise software in the last 5 years. The question is no longer whether humanoid robots will enter industrial ecosystems. The question is whether companies are preparing for that integration. Are technical teams ready to maintain and supervise these systems? Are engineers adapting their skill sets? And if you work in manufacturing or automation, I'm genuinely interested in your perspective. Do you see humanoid robots as realistic integration within 5 years in your environment? Let me know in the comments. And if you want deeper analysis on automation, AI integration, and real industrial technology trends, that's exactly what we explore here on Patchy Technology.